Hello and welcome to Chemistry Solutions. This tutorial is on balancing chemical equations. In a chemical reaction, atoms are neither created or destroyed, so this means that a chemical equation must have an equal number of each type of atom on both sides of the reaction arrow. We'll start out balancing chemical equations by balancing the elements that occur in only one compound on each side of the equation. Now remember, when balancing chemical equations, you can only change the coefficients in front of the reactants or products in a chemical reaction. You can never change the subscript. If you change the subscript, you're actually changing the identity of the compound. Let's take a look at an example and try balancing this equation. Before we start, we're going to want to take an inventory of how many of each type of atom are on each side of our reaction arrow. So on the reactant side, we have 1 carbon atom, 4 hydrogen atoms, and 2 chlorine atoms. On the product side of our chemical equation, we have 1 carbon atom, 1 hydrogen atom, and 5 chlorine atoms. Now looking at this equation, because we have 1 carbon atom on the reactant side and 1 carbon atom on the product side, carbon is already balanced. So our next step would be to balance the number of hydrogen atoms, and I'm choosing to start with hydrogen because hydrogen occurs in 1 compound on the reactant side, CH4, and 1 compound on the product side, HCl. In order to balance the number of hydrogens on the product side, we're going to want to put a 4 coefficient in front of HCl. Remember, we can only add coefficients, we can never change subscripts. Now if we count up the number of each type of atom we have on both sides, you'll see that we still have 1 carbon atom on both the reactant side and the product side, but now we have 4 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. But by putting a 4 coefficient in front of HCl on our product side, we not only have increased the number of hydrogen atoms on our product side, but we've increased the number of chlorine atoms on our product side as well. So if we look at our new total, we still have 1 carbon atom on our product side, but we now have 4 hydrogen atoms, and we now have 8 total chlorine atoms. 4 from the CCl4 that we had to begin with, and 4 from our 4 molecules of HCl. If we compare the types and numbers of atoms that we have on the reactant side and the product side now, we'll see that we still have 1 carbon atom on each side, we have 4 hydrogen atoms on each side, but on our product side we have 8 chlorine atoms, and on our reactant side we only have 2 chlorine atoms. So in order to balance our chlorine, we're going to add a 4 coefficient in front of our Cl2 molecule. And if we have 4 molecules of Cl2, that now means that we have 8 chlorine atoms on our reactant side. And remember, I chose to add 4 as the coefficient in front of Cl2 because each molecule of Cl2 has 2 chlorine atoms. So if I have 4 molecules of Cl2, that gives me a total of 8 chlorine atoms, which I found just by multiplying 4 times 2. And now that we have the same number of each type of atom on the left side of our reaction arrow and the right side of our reaction arrow, we can consider this reaction correctly balanced. And after you feel that you've correctly balanced your chemical equation, the last thing to check is that your coefficients, which would be a 1 here, we don't typically write, 4, 1, and 4 are in their lowest ratio. Having coefficients that aren't in a lowest ratio does not make the chemical equation incorrect, but typically instructors in classes are looking for the lowest ratio when considering a balanced equation. And typically when balancing your equation using this method, you will come up with the lowest ratio. But it's just one more thing to keep in mind. Let's take a look at another example. Again, I'm going to start by taking inventory of how many of each type of atom I have on the reactant side and the product side. On the reactant side, I have 4 phosphorus atoms, 11 oxygen atoms, 10 from the molecule P4O10, and 1 from the molecule H2O, giving me a total of 11, and 2 hydrogen atoms. On the product side, I have 1 phosphorus atom, 4 oxygen atoms and 3 hydrogen atoms. Let's start by balancing the number of phosphorus atoms. And again, I'm choosing phosphorus because it occurs in one compound on the reactant side and one compound on the product side. And it seems to be, if you follow this method, it'll make balancing the reaction a little bit easier. But you can really balance whichever type of atom you prefer first. Because I have 4 phosphorus atoms on my reactant side, I know that I need 4 phosphorus atoms on my product side. And because I can't change the subscripts of any atom, I have to add my 4 as a coefficient in front of the molecule H3PO4. By adding 4 as my coefficient in front of H3PO4, I have not only now changed the number of phosphorus atoms I have, but I've also changed the number of oxygen atoms and hydrogen atoms. So to determine the number of oxygen atoms I now have on the product side, I multiply the coefficient by the subscript on the oxygen, which gives me 16. And to determine the number of hydrogen atoms I have on the product side, I multiply the coefficient by the subscript on the hydrogen, which gives me 12 hydrogen atoms. Now that I've balanced the number of phosphorus atoms on the reactants and product side, I'm going to balance the number of hydrogen atoms next. So using the new number of atoms that I've calculated, I have 12 hydrogen atoms on my product side. In order to give me 12 hydrogen atoms on my reactant side, I know that I'm going to need to add 6 as a coefficient in front of H2O. So 6 times the subscript on H, which is 2, now gives me 12 hydrogen atoms on my reactant side. But again, because I put a coefficient in front of the entire molecule, I've not only changed the number of hydrogens on the reactant side, but I've also changed the number of oxygens. I now have my original 10 oxygens from the compound P4O10, but I have an additional 6 oxygens because I have 6 H2O molecules, which gives me a total of 16. Now you can see in this case, balancing our hydrogen automatically balanced the number of oxygen atoms on the reactants and product side. This isn't always the case. Sometimes you need to go balance that third type of atom, but sometimes you'll be fortunate enough that it will just work out and save you a little less work. And now because I have the same number of each type of atom on the reactant side and the product side, I can consider this reaction correctly balanced. Thanks for listening to Chemistry Solutions.